Hello children, welcome to my class. In this session we will study refraction of light at plane surfaces. What is refraction? How do the light refracts? We will study in detail. Children, in your previous classes you studied that light travels in straight line. It is known as what we call it rectilinear propagation of light. What we call it rectilinear propagation of light. So, how long the light travels in straight line? When light travels in one transparent medium only, observe this one, observe this definition. When light travels in one transparent medium only, as long as the light travels in one transparent medium or same transparent medium, then it travels in straight line. What happens if the light travels or if the light enters into another medium? We will discuss in detail with few examples and animations. Children, observe this arrow. When this arrow is observed from an empty glass, see this one. The direction of the arrow is towards the right side when it is seen from an empty glass. But here, when the same arrow is observed with a glass with full of water, the direction of the arrow changes. Observe this one. Here it is towards the right side, the arrow is directed towards the right side, whereas here the arrow is directed towards the left side. Why the direction of the arrow changes when it is seen from a glass with water? Let us discuss. Children, observe this one. Another example, when the pencil kept inside the water, see, the pencil appears slightly raised above the surface. Observe this one. You will find the pencil appears bent at the surface of separation of water and air. Okay, why do this bending of the pencil takes place? Let us discuss. See, this bending of light rays, observe this one. The bending of light rays at the surface of separation of two mediums is called refraction. It's called refraction, or the change in the direction of the light as it travels from one optical medium to another optical medium. This phenomena is known as what we call it refraction. Refraction is a phenomena in which bending of light rays takes place at the surface of separation of two medias. Children, I will try to make the concept crystal clear to you with an animation. Let us assume a transparent medium. A transparent medium. This is the transparent medium. Let us consider this is the denser medium and this one is the rarer medium. This is the rarer medium. Okay. Let us assume a ray which is incident on the surface. On the surface. See this one. This is the surface of separation. Observe this one. This is the boundary of separation of two medias. Observe this one. Above this boundary, there is the rarer medium. Below this boundary, there is the denser medium. So, the bending of the light rays takes place at the boundary of the surface. We call this boundary as the interface. We call this boundary as the interface. Okay, this is the incident ray and this one is the refracted ray. Observe this one. This is the refracted ray. Now, this is the normal drawn at the point of incident. This is the point of incident. Observe this one. This is the point of incident. At this point of incident, a normal is drawn to the surface. A normal is drawn to the surface. This is the normal. So, this is the angle made by the incident ray with the normal. Angle I is the angle made by the incident ray with the normal. And this angle R is the angle made by the refracted ray. Refracted ray in the sense the light which bends in the medium. Why the light is bending here? Because there is a surface of separation of two medias. Above the separation, this is known as the interface. Above this there is air, and below this there is the denser medium. So light is traveling from rarer to denser medium. Light is traveling from rarer to denser medium. So when light travels from rarer to denser medium, it bends towards the normal. It bends towards the normal. Here, if you observe it carefully, the angle of refraction is less than the angle of incident. Observe this one. This is the angle of refraction. This angle of refraction is less than angle of incident. Now, velocity of light in rarer medium is more than the velocity of light in denser medium. Remember that here I am using rarer medium and denser medium. Optically rarer and optically denser. What does it mean? We will discuss one by one in detail. Now, let us consider another phenomena. See this, observe this animation. Now, the light ray is traveling from denser to rarer. See this one, the light ray is traveling from denser to rarer. This is the incident ray. Observe this one, this is the incident ray. Now, the light ray is traveling from denser to rarer medium. This is the point of incident. Observe this one, this is the point of incident. Now, a normal, this is a line drawn perpendicular to the surface, okay, at the point of incident. The light ray bends away from the normal. This light ray is known as refracted ray. What we call it? Refracted ray. Now, this is the angle made by the refracted ray with the normal. This is the angle made by the incident ray with the normal. So here in this case, light ray is traveling from denser to rarer. When light ray travels from, observe this one, when light ray travels from denser to rarer medium, it bends away from the normal. It bends away from the normal. Observe this one. It is bending away from the normal. Observe this. It is bending away from the normal. This is angle of refraction. This is angle of refraction. This is angle of incident. See this one. This is angle of incident. This one is known as the angle of incident. In this case, here the angle of incident is less than the angle of refraction. The angle of refraction. Okay, let us discuss why does the light bends? What is the reason behind the bending of light? The only reason is, I told you earlier, light travels in straight line as long as there is no change in the medium. As long as it travels in the same medium, there is no change in its speed. Okay, change in speed of light as it goes from one transparent medium to another transparent medium is the reason for bending of light rays. So this bending of light rays is known as, what we call it, refraction. What we call it? Refraction. Okay, the boundary which separates the two medias is known as, what we call it, interface. What we call it? It is known as interface. Here the interface is indicated with white line. Observe this animation carefully. This is the interface. This is the interface. Next, this is the incident ray. Next, this is the refracted ray. And this yellow dotted line shows the normal. If you observe this animation carefully, here the refracted ray moves away from the normal. It is moving away from the normal. Why? Because the speed of the light ray increases as it enters into rarer medium from the denser medium. Are you clear? Now, let us discuss optical density and denser medium and rarer medium. What do you mean by optical density? Optical density is defined as how much a material is able to slow down the light. How much a material is able to slow down the light. See, the normal density in the case of materials, mass per unit volume is known as density. Are you clear about that one? Here, optical density is different. Optical density is defined as how much a material is able to slow down the light. Okay, the speed of light in rarer medium is more and the speed of light in denser medium is less. As you know that the speed of light in vacuum is 3 into 10 to the power of 8 meters per second. Okay, 3 into 10 to the power of 8 meters per second. Okay, what are the units here? Meters per second. What are the units? Meters per second. Light travels with a speed of 3 into 10 to the power of 8 meters per second. Okay. Next, when there is a change in the medium, the speed of the light changes. So, when the speed of the light changes, the bending of the light rays takes place. Okay. Where it bends towards normal or away from the normal, it can be decided, okay, depending on the medium, whether it is entering from rarer to denser or denser to rarer. Are you clear? When the light ray enters from rarer to denser, it moves towards the normal. When it enters from denser to rarer, it moves away from the normal. Are you clear? I hope I made the concept crystal clear to you. Okay, we will discuss Snell's law in our next class and refraction through a glass slab and what is total internal reflection. We will discuss all these things in our next class. Thank you children for watching my video and do subscribe and share and support my channel. Thank you.